Hi guys, welcome to a new video. Today in this video we'll be discussing this Leetcode contest problem called path existence queries in a graph 1. So I hope you have read the problem statement. Now let's understand what the problem is. So you will be given n nodes labeled from 0 to n minus 1, and you are also given an array called nums of size n, and the value of this nums array values are sorted in non-decreasing order, a1 a2 a3 dot till an. These values are in non-decreasing order. Now an edge would exist between node I and node j if the following condition holds. So this nums I minus nums j, this absolute value has to be less than max diff, and this max diff will be provided in the question, right? Now you are also given a list of queries where ith query means ui vi. So this is basically a source node and a destination node, and you have to tell whether there exists a path between source node to destination node. So this is the question. So let's see the constraint of the problem. The value of n is in the order of 10 to the power 5, fine, and num size is also in the order of 10 to the power 5. Also the number of queries that we have to process is also in the order of 10 to the power 5, fine. Now let's see what is the brute force approach to solve this problem. From the given array you can build a graph from scratch and then apply something called TFS. With source node as u, and then you will check whether it is possible to reach your destination node v. If yes, then you can return true, otherwise we will return false. So this is the brute force approach. Since the constraints are in the order of 10 to the power 5, this is going to give you TLE. Okay, so what is the optimal approach to solve this problem? Suppose this is your nums array a1 a2 a3 a4 dot till an. This is your nums array, right? Consider that this is the first node which corresponds to your source node u, and this node corresponds to your destination node v. For the time being, suppose that there is a path exists between u to v. This path exists. Since this path exists, we can tell that, and then this a2 and a3 corresponds to some intermediate node. Okay, just some intermediate nodes. Since this path exists, we can tell that it is also possible to go from a1 to a2, a2 to a3, and a3 to a4. Since all the values are given in the sorted order, it is always possible. So in the reverse way, if we think it in the reverse way, if we can jump between the consecutive nodes, then we can conclude that it is also possible to go from one terminal to another terminal, also possible, right? And this is what you have to check, whether for a given u comma v pair you are able to travel from u to v. Now the real question is whether it is always possible for any two given nodes. The answer is no. So when it is not possible, Suppose there is a case, mm, suppose this is am, and am minus 1 corresponds to some nodes x and y, and the difference between am plus 1 and am, it is greater than your max diff, which means that there is no path between x node to y node. Now since there is no path between x node to y node, we can conclude that we cannot build any path from this segment to this segment on the left of x to any segment on the right of y. Right? Since this difference is already greater than max diff, any attempt to make edges between these two segments will fail. Right. Now we can observe that from this we can observe that this entire array will be splitted into segments, right? And within the same segment you can go from one node to another node without any problem, but it is not possible to go from one node which belongs to some segment 1 to some other segment says 2. It is not possible. Why it is not possible? Since this gap between the junction, this gap is already greater than max diff, you cannot have this path, right? So this is the observation, and if you can answer the queries in constant time or in some logarithmic time, whether your u and v belongs to same segment, then you are good to go. Now the question is, how will you answer this, whether two nodes belong to same segment or not? You can use something called DSU, disjoint set and union find data structure. But is there a requirement to, like, it is really needed? Can you avoid DSU? The answer is yes. Now why can you avoid DSU? Since this graph is not a dynamic graph, or in simple words, since the shape of the graph is not changing as you process the queries, you can simply maintain a parent array and assign the first node of your segment as the parent of all the other nodes, including the first node, obviously. So make this node as the parent of all the other nodes in the same segment, and while processing your queries, you will compare the parent of u and parent of v. If those two belongs to same segment, then you can return true, otherwise return false. Now let's see the code. Okay, here we are creating this parent array. ULP means ultimate parent, whatever. So the parent of the first node will be the first node itself, because the first node has to be the part of some segment and it is the starting node of the segment, so we'll assign it to itself. Then we'll process the nums array and we will inspect the consecutive difference diff. If the difference is smaller than equals to max diff, then we will consider the next node as a part of the same segment and assign the parent of the next node with the parent of the current node. But if the above condition fails, we will start a new segment and assign the parent of that entire segment with the starting node. Okay, once we do that, we will process the queries, and for each queries we will check the parent for node u and parent for node v. If they are same, will store true, otherwise we will store false, then we will return the answer. So I hope you have understood the problem. Give a like. I hope you have enjoyed. See you in the next video. Bye.